Okay, hello. And today we're going to start Chapter 12, and this is going to be a new topic, and it's going to cover regression analysis and also correlation coefficients and correlation. So we're going to start with the basics, and we're going to start with scatter plots. And we're going to talk about looking at relationships between two variables. And then going from there, we're going to see if those variables have a significant relationship or an association with them, and what we're going to call correlation. And then from there, we're going to test for the significance of that correlation if it seems like there is one. And then from there, we're going to say, okay, if there is a significant relationship, what is the, what's the word I'm looking for? The behavior of that relationship. I don't know if that's the right word I want to use. The nature of the relationship. That's the word I want to use. So we're going to start with the idea of two variables and how we can look at, see if there's a relationship between two variables. Okay, so when we talk about correlation, or we talk about two variables, we want to, some of the questions we ask is, okay, is there a relationship between the two variables? And if there is a relationship, is it a strong relationship? What kind of relationship is there? And if there is a strong relationship, if there is a significant relationship, what's the nature of the relationship? How would I describe the relationship? And so that's what we're going to talk about. And the first step to investigating whether there's a relationship between two variables is a scatter plot, a visual display. Okay? So what is a scatter plot? A scatter plot is a way of just looking at two variables and seeing if there's a relationship between them. So for example, I might want to look at length and width. And let's say I'm looking at different leaves, right? Let's say I'm looking at the width and length of leaves of a particular plant. And I want to know, is there a relationship between the length of the leaf and the width of the leaf, or leaves? So let's say I take a random sample of, let's say, 20 leaves from a group of plants. And so I plot these values. So basically I measure the width and I measure the length of each leaf. So the dot, so on a scatter plot, each dot represents a leaf. And so as I plot my values, right, I might end up getting something that maybe looks something like this, where each leaf, right, so let's take this one here. So each dot represents a leaf that has a particular length and a particular width. So they're ordered pairs, right? So as you can see from the scatter plot, we can see from a scatter plot whether there is a relationship or seems to be a relationship. Now, what kind of relationships can we have? We can have relationships that are straight lines or curved, right? So we could have something that is a straight line or is a curve. But the first thing we do is when we plot our scatter plot, and look at our scatter plot, is to see, is there a pattern? Is there a discernible pattern? Like for example, in this case here, I can see that, man, it does look like there's a linear pattern. It does look like it's a straight line. It looks like it goes like something like that, right? Through the data. So it looks like it's a linear, so it looks like it's a straight line. And the dots are pretty close to the line, to a straight line. So the strength of the relationship seems to be pretty strong, okay? And what else? As the length of the leaf increases, so does the width, okay? So it's going in a positive direction, okay? So anytime we see something like this, we're going to try to figure out, okay, is it linear or is it nonlinear? Is it curved? Is it strong, weak, or moderate? And is it positive or negative? Okay, so based on a scatter plot, and there you can get different scatter plots. So here are the different things. Okay, so when you look at a scatter plot, here are the different things that you can get. Okay, so for example, linear versus nonlinear. So linear versus nonlinear, linear, you're going to get something that either looks like this, right? Right? Or you're going to get something that looks something like this, right? Okay. Now, if you get something that looks like this, well, that's definitely not linear. Okay, so this would be linear, this would be linear, this would be nonlinear. Okay, now this here we would call negative association. So it has a negative slope, right? Think of a line. If you draw a line through it, right? The slope of this line has a negative slope, right? If you draw a line through this one, it has a positive slope. So we would call this a positive correlation, positive association. Okay? So both of these would be linear. This would be nonlinear. Okay? Now, both of these here, now as far as strong, moderate, and weak, both of these here we would consider strong because look how tightly around a line it is. Even this one would be strong, but it's a nonlinear. Okay? So now, as far as the strength of the relationship, now that it's a little bit subjective. So when you look at graphs, you got to understand it's subjective, right? So at this point, we're just dealing with what it looks like. Okay? So let me draw 3 different graphs. So for here, like I said, this, and I'm just going to use this as an example. So this would be definitely like a strong association. Okay? And then maybe if I have something like this. Okay. Yeah, maybe a little tighter. Okay. And let's say I have something like this, maybe. Okay. So now if you look at these here, this one I would say is strong. Look how tightly the dots are around a line. This one might be what we would consider moderate. And this one would be weak. Or even if it was like a snowstorm where it just didn't have any discernible pattern, it would just be no correlation, right? So this would be like weak or no correlation. This would be moderate, and this would be strong. So this would be like a strong positive, a moderate negative slope, and this would be a no correlation at all. Keep in mind, we're going to be dealing with linear correlation for this class. So we're not going to be dealing with nonlinear relationships, even though they do exist. So there's linear versus nonlinear. There is strong, moderate, and weak, or no correlation. And finally, there's one more piece. I'm not. Let me think. It's not coming to me. It's the, so we got strong. Oh yeah, negative, positive. Yeah, of course. Never mind. So we've got the linear versus nonlinear. we've got strong, moderate, weak, or no correlation. So those are the four. So, and then the other one is whether it's negative or positive correlation. So the other thing too is when we look at negative correlation versus positive, so this would be positive, okay, correlation. This would be a negative correlation or negative association. Now, the one thing about positive correlation is also called direct correlation, okay, which means, so if these are X versus Y, so that's typically what we have, right? So in direct correlation, as X increases, Y increases. So, and as X decreases, Y also decreases. So that's what we call positive correlation. So as X increases, Y is also increasing. So the slope is positive. Okay. With negative correlation is, or negative association is also called inverse correlation or association, which means as X increases, Y decreases, or as X decreases, Y increases. So we also call it that from time to time. So again, just understand negative and positive, direct, inverse, mean the same thing. Okay? So now, if we don't see any discernible pattern, then we're done. There's no reason to go any further, right? We're not going to investigate two variables if the scatter plot doesn't show anything. Okay? If there's no pattern, then there's nothing to investigate. But what if we do get a pattern? What if we get something that looks like this or this? Then the next step is to quantify that relationship. And that's where the correlation coefficient comes in. And what we call the Pearson product moment correlation coefficient, or just correlation coefficient for short. And so that's going to be the next thing I want to talk about. So next time, we're going to talk about how do we quantify these values. So once we see that we have something like this or this, how do we measure that relationship? How do we measure and quantify the strength of that relationship? We're going to talk about that. And we're only going to talk about linear relationships. So we're not going to deal with nonlinear relationships. We're only going to deal with relationships that are modeled by a straight line. Okay? So in other words, we're going to be dealing with this equation here, y equals mx plus b. It's going to have a slightly different form, but we're going to be talking about, hey, what's the best line to fit the data? But that's going to come later. Okay? So next time we're going to talk about correlation coefficients and how to calculate them, and how do we know if our correlation coefficient is significant. And that's going to bring up another hypothesis test. Okay, so I'll see you next time. Thanks.